Now, if you're a student who may happen to be doing things in Alex, doing things in the homework, less than ethically, let's put it that way. I want you to know that even if you think you're being stealthy, it is actually very obvious to me. And normally when I say something like that, I get a student who emails me, am I one of the students you're talking about? Please don't ask me that, because it makes me look deeper at your case. And if there's something there that's suspicious, I don't need to see that. Let's Valerie cherish that up there. I don't need to see that. But when I do come across these things, what sort of things am I talking about? A problem like this, taking 10 to 15 seconds, maybe even less. If you use one of those apps where you take a picture of it, you get the answer really fast. You can't do this by hand that fast. So when I see quick times, it means one of two things. It means you're not actually working it out, or it means you are really good at this. And when I say really good at this, I mean there's no amount of stress that's going to make you forget how to do this come test time. Because in order to solve this, you first need to distribute to clear the parentheses. That's 36x squared plus 18x. And then we have minus 10x. Nothing to distribute or simplify on the right side. If I combine positive 18x minus 10x, that would be positive 8x. 18x minus 10x is 8x, equals 8x plus 25. I'm going to go ahead and get everything on one side and 0 on the other by subtracting 8x and subtracting 25 from both sides. Minus 8x and minus 25. That's going to give me my 0 on the right. 8x minus 8x cancels away. So we're left with 36x squared minus 25 equals 0. I'm going to go ahead and write that up top. To continue, we factor. This is a difference of squares. That would be 6x squared, and this would be 5 squared. Difference of squares factors as two things, 1 plus, 1 minus. 6x, use a different marker. 1 plus, 1 minus, 6x and 5. 6x and 5. Two things multiplied together equaling 0 either means the first thing, 6x plus 5 equals 0, Or the second thing, 6x minus 5 equals 0. Subtract 5 from both sides, 6x equals negative 5. Divide both sides by 6, x equals negative 5/6. Over here, add 5 to both sides, 6x equals 5. Divide both sides by 6, x equals positive 5/6. So x equals negative 5/6. X equals positive 5/6. Those are the two parts of our answer. I say to you, 15 seconds, really? That wasn't directed to anyone in particular. I'm purposefully trying to avoid having these conversations this semester. So you're not fooling me. If this is something you're doing, if you are using apps to solve equations for you, I've given fair warning, you're only hurting yourself. Good luck in the future. That's all I have to say to that. Great majority of you are doing what you're supposed to. You're struggling through the work when you need to. That is how you learn. You ask questions when you need to. That's how you learn. Trying to get homework grades, even though you don't understand the material. And then, I don't know. I'll never understand why some students do the things they do. Speaking of doing, let's do another. (5a) times the quantity 2a minus 3 plus 4 times the quantity a plus 1 equals 3a times the quantity 3a minus 2. First step in solving any equation of any type is clear parentheses using the distributive property. Hopefully you're seeing today the only really new thing we've done is the zero product property. Everything else is other things coming together. 5a times 2a is 10a squared. 5a times negative 3, that's negative 15a. 4 times a plus 4a. Positive 4 times positive 1 plus 4 equals 3a times 3a, 9a squared. 3a times negative 2, negative 6a. Negative 15a plus 4a. Wait a minute, what am I doing? Step 1 of solving any equation, distribute to clear parentheses. We see parentheses and we're like, no, 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 no. I said, no, no, we don't want parentheses. Can't believe that worked as well as it did. Okay, second step, once the parentheses are gone, combine like terms on the left, combine like terms on the right. We don't have any on the right. We do have some on the left, negative 15a plus 4a. That's negative 11a. Negative 15 plus 4 is negative 11, so negative 11a's. Plus 4 equals 9a squared minus 6a. Okay, so no parentheses left. Like terms have been combined on the left and the right. Now we solve. This isn't linear though, so we're not just going to start moving things around, variables on one side, other things on the other. That's linear. We have a squareds. This is going to be quadratic. And what is the first way we try to solve a quadratic equation? Because it's the easiest, because all we have to know is factoring. Get everything on one side, 0 on the other, factor and solve. Show of hands, I can't see, but how many people understand what's going on right now? Good. Because what are we doing? We're solving quadratics by factoring. How are we doing it? By getting everything on one side, 0 on the other, factoring and solving. Everything from here to here, that's old. Now we're going to go from the old to the new. I'm going to subtract the 9a squared from both sides. And I'm going to add the 6a to both sides, because that gives me 0 on the right. On the left, 10a squared minus 9a squared, that's just a single little a squared, one of them. Negative 11a plus 6a, that's negative 5a, because negative 11 plus 6 is negative 5. And don't forget, we have this plus 4. So once everything is on one side and 0 on the other, what we have, and I'm going to go ahead and write it up here to give myself more room, is a squared minus 5a plus 4 equals 0. Everything on one side, 0 on the other. Factor and solve. We need numbers to put in here. Factoring an a squared, so a and a. Nothing to multiply with the 4, so we're just looking for things that multiply to positive 4, add to negative 5. It's like all of our factoring work is coming home all at once. I've missed you factoring. The numbers are going to be negative 4 and negative 1. Negative 4 times negative 1 is positive 4. Negative 4 plus negative 1 is negative 4 minus 1 is negative 5. Put in our minus 4. Put in our minus 1. Be careful not to say that those were our answers. They're not our answers. They're not what a equals. They're what we're putting in to our factors. And now we have two things multiplied together equals 0, which means either the first a minus 4 is 0, or the second a minus 1 is 0. Add 4 to both sides. A equals 4. Add 1 to both sides. A equals 1. A equals 4 or A equals 1. We need them both. And if we put it into a set, it's just a set with our two answers, 1 and 4. Normally at this point, I'd be like, any questions? No one would really ask one anyway, but hopefully you don't have any. Just remember, this is a video. If there's something you don't understand, you've got the Adam Sandler click power. You can control me. You can rewind me. You can make me say this as many times as you want. You can make me say this as many times as you want, as many times as you want. You have complete control over rewinding this video. having me repeat things. Remember, how are we ready for the test? What does it mean to be ready for the test? I'm glad you asked. It means that you can go to any lecture video that this test is going to be over. You can do any problem, go to any problem, pause it at the beginning, and you can do it all by yourself without any help, without any hints, without looking at any work, without any notes. And you do the same steps I do, and you understand why each step is the way it is. And then when you finish, you hit play and you see, hey, I did it right. If you can't do that with every problem in every lecture, you are not ready for the test. That is what being ready means. If there's even one thing in these lectures you don't understand, you need to make sure you understand it. If you don't, you're not ready. To that, unless you know it backwards and forwards to the point that no stress can make you forget it, there's always more studying you can do. I say this to address comments like, I thought I was ready, but then the test got put in front of me and everything just left my head. Well, if that's going to happen to you on the test, I almost guarantee that if that same thing came up in the lecture video and we paused it and I said, do it, no help, the same thing would happen. I don't mean to minimize any sort of test anxiety or anything like that. People always ask, are there any tips or tricks you can give me? I am giving them to you. I'm giving them to you all right now. I'm not going to withhold a specific piece like, hey, if you ask me, I will tell you how to pass these tests, but don't tell everyone else. It doesn't work like that. There isn't anything special that I can tell you if you're having trouble. The best thing I can say is everything you need to know to ace the tests, I teach in the lecture. So if you can truly do everything in the lecture on the spot, completely correct, and understand why you're writing the things you're writing, you should ace the quizzes. If you can't do that, then there's still something in the lectures you can be going over that you can be learning. Homework is to help you practice, but the lectures are where I teach you. If you're just doing the homework, you're teaching yourself, and that's not what this class is supposed to be. You can go on YouTube and teach yourself math for free. You're paying for a class. You're paying for my instruction. And again, if you're watching this, then I'm preaching to the choir. People who really need to hear that are the people that aren't watching. So thank you for being here. So I've been saying a series of things multiplied together. That'll work out the same way. Let's say we had -2 times y plus 7 times y minus 1 times 10y plus 3 equals 0. It's the zero factor property still. We have 1, 2, 3, 4 factors multiplied together, which means one of these 1, 2, 3, 4 factors at least must equal 0. So we set each of these 1, 2, 3, 4 factors equal to 0. -2 equals 0. Y plus 7 equals 0. Y minus 1 equals 0. 10y plus 3 equals 0. -2 equals 0, that's false. There's no solution there. Y plus 7 equals 0. Subtract 7 from both sides, we get y equals -7. Y minus 1 equals 0. Add 1 to both sides, we get y equals +1. 10y plus 3 equals 0. 10y equals negative 3. Y equals negative 3 tenths. Because I divided both sides by 10. So the solution set, negative 3 tenths, negative 7, positive 1. I can put these in any order. It doesn't matter. I'm just putting my 3 answers. All 3 need to be there, though. Z cubed plus 3z squared minus 4z minus 12 equals 0. Sometimes we can solve a cubic or a higher power, something that's not quadratic. Sometimes we can solve those using factoring as well. That last one we looked at, that was technically a cubic because there were 3 terms with y. If we multiplied that all out, we would get a negative 20y cubed in the front. But we were still able to solve it using factoring. So let's use factoring here. It would be really nice if we just factored out something with a z and ended up with a nice quadratic, but since this term here doesn't have any z's, we can't factor any z's out. 1, 3, 4, 12, there isn't a number. There isn't a factor in common to each of the terms at all. So there's nothing we can factor out. Do we have a type of factoring we can do when we have 4 terms? When we have 4 terms and we can't do anything else with it, we try to do factoring by grouping. So here we go. Group the first 2. We can take out a z, just a z squared. We can take out a z squared. We take out the lowest power shown. Z cubed, z squared, z is in common. Lowest power shown is 2. Z squared times z is z cubed. Z squared times positive 3 is 3z squared. After our first grouped area, we have a minus. Remember, that means we have to factor out at least a negative. 4z and 12, we could actually take out a negative 4. Negative 4 times z is negative 4z. Negative 4 times positive 3 is negative 12. Factor out the z plus 3. What are we left with? Z squared minus 4. Hey, 2 factors. Is this completely factored? No. No, it is not. What can we do to keep factoring? Is there some like greatest common factor we can factor out? No, that's not it. What do you see? What can we factor? Yeah, z squared minus 4, that's a difference of squares. So our z plus 3, this piece is z plus 2, z minus 2. Again, we went over all this factoring in the past. Now we have 3 factors equal to 0. Z plus 3 equals 0 gives us z equals negative 3. Z plus 2 equals 0 gives us Z equals negative 2. Z minus 2 equals 0 gives us Z equals positive 2. Negative 3, negative 2, and positive 2. Those are our 3 answers. Z cubed, 3 answers. 3, 3. Funny how that works. Now you might be saying, by the way, if you got how I got these, feel free to do it that way. Once you get it in factored form, you can solve those in your head. But if you need to write these steps out, what did I do? I went Z plus 3 equals 0, Z plus 2 equals 0, Z minus 2 equals 0. Subtract 3 from both sides, Z equals negative 3. I saw plus 3. The answer is going to be minus 3. Sorry for the glare. Z plus 2 equals 0. I'm going to subtract 2 from both sides. Z equals negative 2. Z minus 2 equals 0. I'm going to add 2 to both sides. Z equals positive 2. Z plus 2 factor gives us an answer of Z equals negative 2. Z minus 2 factor gives us an answer of Z equals positive 2. We get fractions when we have numbers in front because that's what we would divide by. Objective 2 in this topic: solve problems that can be modeled by polynomial equations. A model rocket is launched from the ground. Its height h in feet at time t seconds is approximated by the equation h equals negative 16t squared plus 112t. Find how long it takes the rocket to return to the ground. So let's set the equation equal to 0 and factor, because the ground is a height of 0. So h equals 0, we're looking for t when that's happening. So negative 16t squared plus 112t equals 0. We can factor out negative 16t. That leaves us with t minus 7. Set each factor equal to 0 and solve. Negative 16t equals 0, or t minus 7 equals 0. Solving those gives us t equals 0 or t equals 7. So when does it return to the ground? T equals 0 is the start. That's when it's leaving the ground for the first time. And then at t equals 7, at 7 seconds, the rocket returns to the ground. Let's talk about the Pythagorean theorem. In a right triangle, the sum of the squares of the lengths of the two legs is equal to the square of the length of the hypotenuse. Leg A squared plus leg B squared equals the hypotenuse squared. If you've never heard the term hypotenuse before, it is the side of a right triangle that's directly across from the right angle. The other two sides are called legs. You might have seen the Pythagorean theorem before in another form. A squared plus B squared equals C squared. So we use the Pythagorean theorem in problems that involve right triangles. Find the length of the shorter leg of a right triangle If the longer leg is 10 miles more than the shorter leg, and the hypotenuse is 10 miles less than twice the shorter leg. Wow, miles. This is a big triangle. So the shorter leg is what we're looking for. That's x. If the longer leg is 10 miles more than the shorter leg, so x plus 10, and the hypotenuse is 10 miles less than twice the shorter leg, so 2x minus 10. Remember, always draw a figure if we can. So we've read the problem, we've made our figure, and we've labeled our sides based on the descriptions in the problem. If x is the length of the shorter leg, then x plus 10 is the length of the longer leg, and 2x minus 10 is the length of the hypotenuse. Let's put these values in the Pythagorean theorem. So 1 leg squared would be x squared, plus the other leg squared would be x plus 10 squared, equals the hypotenuse squared. That would be 2x minus 10 squared. Be so careful when you solve. X plus 10 squared is not x squared plus 100. Remember, it's x plus 10 times x plus 10. We FOIL it with itself or we use the special formula. Same with the 2x minus 10 squared. We FOIL it with itself or we use the special formula. So x plus 10 squared gives us x squared plus 20x plus 100. 2x minus 10 squared gives us 4x squared minus 40x plus 100. We have some like terms we can combine on the left. X squared plus x squared is 2x squared. Everything else stays the same. Now we want to get everything on one side, 0 on the other, so we can factor and solve. Let's move everything to the right because it makes more sense for us to do 4x squared minus 2x squared. That keeps it positive. So subtract 2x squared, subtract 20x, and subtract 100. That leaves us with nothing on the left. That's what we want. 4x squared minus 2x squared is 2x squared. Negative 40x minus 20x is negative 60x. And 100 minus 100 goes away. We can factor out a GCF. That would be 2x. We're left with x minus 30. That is our factored form, so set each factor equal to 0. 2x equals 0, x minus 30 equals 0. And that gives us x equals 0 and x equals 30. Now, obviously, 0 can't be the length of a leg of a triangle. So although it satisfies our equation, it can't be a solution for the problem we were presented. But if we let x equals 30, then x plus 10 equals 40. 2x minus 10 would be 60 minus 10 would be 50. Check that in the Pythagorean theorem. 30 squared plus 40 squared. That's 900 plus 1600. That's 2500, which is the same as 50 squared. So the Pythagorean theorem does check with our value of x equals 30. So the length of the shorter leg is 30 miles. And that's all we were asked for in this problem. We weren't asked for all 3 legs. We were just asked for the shorter leg. The topic is reading graphs and the rectangular coordinate system. The first objective in this topic is plot ordered pairs. This is a Cartesian plane, also known as a coordinate plane or an XY plane, or a rectangular coordinate system. Have you ever played Battleship? When you're playing Battleship, you would call, for instance, D4. And D4 would mean you go and find the D on one end and the 4 on the other end. And where the 4 and the D meet, that's where you would strike D4. A Cartesian plane, a rectangular coordinate system, works the same way. This horizontal axis is the x-axis. This vertical axis is the y-axis. The x-axis is just your standard number line. 0 in the middle, positive numbers to the right, negative numbers to the left. The y-axis is a number line straight up and down. 0 in the middle, positive numbers up, negative numbers down. I'm going to go ahead and clear these numbers out of here just to declutter a bit. And I'll indicate positive, negative again. So positive numbers to the right, negative numbers to the left, positive numbers up, negative numbers down. This is separated into 4 quadrants. We start numbering our quadrants in the top right, and we move counterclockwise. So that's against the direction of a clock. A clock goes this way. That's clockwise. We go counterclockwise when we're numbering. 1, 2, 3, 4. Okay. And we use Roman numerals. 1, 2, 3, 4. Quadrant 3 is lower left. Quadrant 1 is upper right. Quadrant 2 is upper left. Quadrant 4 is lower right. A point, say this one here, 1, 2, 3 to the right, and 1 up, would have both an x coordinate based off of its position on the x-axis and a y coordinate based off of its position on the y-axis. And these coordinates are going to be of the form x comma y, where x and y are in parentheses. So in parentheses, there are 2 coordinates. The first is an x, the second is a y. And this one here, the x, 1, 2, 3, positive 3, the y, 1, positive 1. So this point would be the point 3, 1. Notice it's a positive number and a positive number because it's in quadrant 1. And anything up here in quadrant 1 is going to have a positive x because it's to the right, and it's going to have a positive y because it is up. So all points in quadrant 1 will be positive, positive. All points in quadrant 2 then are going to be negative positive because the x is negative. It's going to be to the left, but the y is positive. It's going to be up. 3. Quadrant 3, the x will be negative because it's to the left. The y will be negative because it's down. Quadrant 4, the x will be positive because it's to the right. The y will be negative because it is down. When we draw ourselves a coordinate plane, you don't have to put in quadrants 1, 2, 3, and 4. You don't have to put plus, minus. All you have to do is make the coordinate plane, label your x-axis, and label your y-axis. That's all you need, an x and a y. So let's find the point -3, 5. Well, our first coordinate is the x, our second coordinate is the y. The x should be -3, and the y should be 5. Now, I'm not going to put a mark here and a mark there, but I am going to kind of tell you to imagine where these intersect, just like Battleship, an x of -3 and a y of +5. Just like Battleship, where they meet is where our point will be. And let's say it's point B. We can call that B. Zeros are where things might get a little cloudy for you. So let's learn a little bit about our zeros here. First of all, we got the double zero, and it's going to be right here because it's a 0 on the x and it is also a 0 on the y. This actually has a special name. That special name is the origin. Let's say we had this point right here. In fact, let me change the position of that. That's under the light spot. Let me go with this one down here. The x is still going to be 0 because it's not going left or right any on the x-axis, but it did go down. It went down 1, 2, 3, 4, 5. So this point would be 0, -5. We'll talk about that in a second, but I also want to talk about this point right here. Now the x is 1, 2, 3, 4, but the y has not moved any from 0. So the y is 0. What I want to point out here is that something that's directly on the x-axis, the horizontal axis, has a y of 0. Something that is directly on the y-axis has an x of 0. These types of points that happen to fall right on the axes are called intercepts because they intercept the axis. An x-intercept intercepts the x-axis. It has a number for x, but a y of 0. So an x-intercept has a y of 0. A y-intercept intercepts the y-axis. It is on the y. It has a number for y, but an x of 0. The second objective in this topic is determine whether an ordered pair is a solution. Let's say we had the equation y equals x plus 2. A solution x, y would be an ordered pair. And by the way, that's what we call these, ordered pairs, because order matters. It's a pair of numbers where the order matters. The first is always x, the second is always y. If you switch them around, it wouldn't be the same thing because the first is always x and the second is always y. So a solution, xy, would be an ordered pair that makes the equation a true statement. Now, maybe you're suffering from whiplash right now. You might be going, hold on, you were just talking about a graph. You were putting points on there. Now we're talking about an equation. Tell me, what's happening? Well, what's happening is I'm showing you that an ordered pair, those things that we're putting on the graph as points, would express a solution to an equation if it's true. So let's test out a few possible ordered pairs and see if they are solutions to this equation. Let's test 0, 2. Let's test -4, -2. Let's test 2, 4. Remember, when we see an ordered pair, what we are seeing is x and y. So let's test this one. X is 0, y is 2. That one's true. So that is a solution. Let's test the second one. X is -4, y is -2. So -2 equals -4 plus 2. -4 plus 2 is -2. Boom, that one checks too. So that one's a solution. Let's check this one, 2, 4. X is 2, y is 4. That checks out. So all three of those are solutions. Does that mean everything's a solution? No. It means that these three are. But guess what? I picked these three because I knew they were. Let's try 1, 8. X is 1, y is 8. That one doesn't check. That one's not a solution. It's only a solution if it satisfies the equation. If when we plug in X and Y, we get a true statement. The third objective in this topic is graphing linear equations. Let's bring our coordinate plane back. X, Y. These ones that were solutions, let me go ahead and plot these points. 0, 2 would be an X of 0 and a Y of 2. -4, -2 would be an X of -4, so left 4, down 2. 2, 4, it's an X of 2, 2 to the right, a Y of 4, 4 up. Will you look at that? Well, don't use a cloth as a ruler. That's what we just learned, everybody. A cloth is flimsy. It does not serve the purpose of a ruler. It's much easier to freehand it. But notice, look at these three solution points. They all fall on the same line. That's why an equation that only has x to the first power and nothing higher is called linear. Because if you take all the solutions, they form a line. Points on this line will be a solution. Like here, this is a point on the line. What is that point? -2 on the x, 0. Surely does check. Plug in -2. -2 plus 2 is what? 0. Now, by the way, I want to make a note. I had to be really careful to try to make these equal distant. Because when you're drawing them out, if the tick marks aren't the same size apart, your line's going to get all wonky. You don't want that. So let's go ahead, graph another equation. By the way, that's kind of what we did there. We just graphed an equation. We graphed an equation by plotting points. Let's do the same thing with x minus 2y equals 0. Well, what we can do is solve this equation for y. Now, why would we do that? Well, it'll allow us to pick our x's and then plug them in. Here, I'll show you. If we solve this for y, subtract x from both sides, subtract x from both sides, divide both sides by -2, y equals negative divided by negative is positive, y equals x over 2. So to get a y coordinate, all we have to do is take an x and divide it by 2. Let's make an xy table. What that means is make a table of x's and y's. Since we're going to want to be able to divide the x by 2, our x's that we pick should be even numbers. And I'm going to pick a couple of negatives. I'm going to pick a 0, and I'm going to pick a couple positives. Unless the table's already given to you, you do not have to pick specific x values. Because the whole purpose of an x is to find the y. -4 divided by 2 is -2. -2 divided by 2 is -1. 0 divided by 2 is 0. 2 divided by 2 is 1. 4 divided by 2 is 2. Now, another thing you could have done is just, we're going to come back to what to do with these points in a second. This is like a pause. This isn't more of the same. This is another thing you could have done. Just start by picking some x's and then plugging them in. So if you plug in -2 and then solve for a y, you'll get your y. It just so happens, since you notice -2, -1, we got that point anyway. It's just that if we were putting in, say, a -1 here and solving, you'd end up with fractions. Those would still be on the line, but for graphing purposes, it's a lot easier if you're graphing whole numbers and then not having to figure out, okay, what's half, what's a fourth. So by solving this equation for y first, when it was still in terms of x, it kind of gave us a clue of what kind of x would give us whole number y's. But really, to draw a line, you only need 2 points. 2 points are enough to make up a line. But let's plot all 5 of these. Give a graph, label y, label x. Looks like we need 4 at least in all directions. Try to keep them equal. If you have graph paper, that makes things a lot easier. So -4, -2, that's an x of -4. A y of -2, that's right here. -2, -1, an x of -2, a y of -1, that's right there. 0, 0 is right there. An x of 2, a y of 1, that's right there. An x of 4 and a y of 2, that's right there. So you can kind of see there's our line. And we put arrows on both sides of the line to indicate that it goes off in both directions forever. So that's graphing an equation by plotting points. Let's do another. Let's do x plus 3y equals 3. Well, I could just start picking a bunch of x's, but seeing that y is multiplied by 3 here, that tells me that there's going to be some weird dividing by 3 stuff going on. So I'm going to go ahead and solve for y. I'm going to solve for y by subtracting x from both sides. So 3y equals 3 minus x. I'm going to divide both sides by 3. And y is going to be 3 minus x over 3. So let's make our x and y table. We know how to get our y's. We're going to pick our x. We're going to plug it in. We're going to get our y. Okay. So I'm going to go ahead and pick a couple negative x's. Ooh. I want to be careful with how we pick again. If I just randomly pick some x's, I'm going to run into the same situation, but it has to be something that I can go 3 off of and then divide by 3. So since we're going to be skipping 3 off of it anyway, if x was divisible by 3 and we did 3 minus that x and divided by 3, we should get some nice even y's. So I'll pick some multiples of 3. -6, -3, 0, 3, and 6. These should work. And this is just me thinking it through. You can just pick a bunch of things if you want until you have 2 that did work, that were graphable. If I plug in -6, 3 minus -6 over 3 would be 3 plus 6 over 3, which would be 9 over 3, which is 3. If I plug -3 in, 3 minus -3 is 3 plus 3 over 3, which is 6 over 3, which is 2. If I put 0 in, 3 minus 0 is 3, 3 over 3 is 1. So 3 minus x over 3. If I put 3 in, 3 minus 3 is 0. 0 over 3 is 0. If I put 4 in, or sorry, if I put 6 in, 3 minus 6 is -3. -3 over 3 is -1. So for x plus 3y equals 3, looks like 6. -6, 3. -6 for the x. +3 goes up. -3, 2. And again, I'm pulling these right out of the table. X and Y just becomes an ordered pair. X and Y just becomes an ordered pair. -3, 2. -3 on the X, 2 on the Y. 0, 1, just pulling it right out. 0 for the X, 1 for the Y. 0, 1 was right there. 3, 0. That's there. 6, -1. 1, 2, 3, 4, 5, 6. Down 1. My lack of foresight, not having a ruler here, means that's the best we're going to do with that line. I am not an artist. Another thing you can do to graph is just identify the intercepts. That's a nice, easy 2 points. So what do I mean there? So 2 points is enough to draw a line. So assuming they don't end up being the same point, let's look for where x is 0 and where y is 0. That'd be finding the intercepts. When x is 0, that's a y-intercept. That'll be our point on the y. When y is 0, that's our x-intercept. It'll be our point on the x. If we plug in 0 for x and solve for y, we get y equals 1. Plug in 0 for x, plus 0 is itself. 3y equals 3. Divide both sides by 3. That's what happened there. Y equals 1. Let's plug 0 in for y. So again, x plus 3y equals 3. If we plug 0 in for y, 3 times 0 is 0. X plus 0 equals 3. X plus 0 is just x. So x equals 3. Now be careful. This is 2 separate points. It's not a point where x is 3 and where y is 1. That is something completely different, unrelated. This is 2 separate points. One where we plugged 0 in for x and got an answer of y. So that's our 0, 1 point. A second point where we plugged 0 in for y and got an x. That's our 3, 0 point. 3, 1, not a point that would satisfy this equation. But once we found our intercepts, the only time this won't work is when it's 0, 0, because that means it'll be the same for both, and we would need to pick another number to get a second point. But once you find your intercepts, all you have to do is plot them. 0, 1, so no movement on the x, but 1 up for the y. 3, 0, no movement for the y, but 1, 2, 3 to the left. There's our 2 points. And we draw our line through them. It's the same one as the one we did those 5 points. But we didn't have to do any weird solving this way. All we do is plug 0 in for x to get one of the points, plug 0 in for y to get the other one of the points. So, new equation. Let's look at 2x plus 3y equals 4. Let's find the intercepts. XY method with the googly eyes, 0 for x, 0 for y, two separate lines. If we plug 0 in for x, this goes away. We're left with 3y equals 4. Divide both sides by 3, we get y is 4/3. For the sake of graphing that, we're going to change it to a mixed number. So 4 divided by 3. 3 goes into 4 once. And we want the fraction remainder. 1 1/3 is our y. 1 1/3. 4/3 is a fine answer too. It's just I know I want to graph it. And if you tell me to graph 4/3 and you tell me to graph 1 1/3, I know which one I'm going to be able to find quicker. Let's go ahead and plug 0 in for y. Plugging in 0 in for y, plus 3 times 0 plus 0. That goes away. 2x equals 4 is what we're left with. Divide both sides by 2. We get x equals 2. If I were to graph these points, I'm going to do the one without the fraction first. X is 2 and y is 0. That's an x-intercept. When x is 0, y is 1 1/3. So if I imagine that between between 1 and 2, this got split up into thirds. 1, 2, so it's 1, 2, 3 pieces. 1 1/3 would be right here. And then use your straight edge. You just fold up a piece of paper. Use your straight edge to draw the line between those 2 points.